Everyone, Mr. Armitage here. In this video, I am doing a fourth version of factoring by greatest common factor, GCF, from chapter 4.4, and it's because this one definitely requires some thinking. Okay, so our greatest common factor here. Well, if we're going to factor by greatest common factor, all terms need to have something in common. And we can see first, okay, all the numbers are divisible by 5. Cool. Let's take out that 5. 5 times w to the 6th plus 5 times negative 5w to the 4th. Okay, just keeping that negative with the other 5 so that everything's positive outside. Plus 5 times 6w squared. When we factor out the 5, we get 5 times w to the 6th minus 5w to the 4th plus 6w squared. Okay. Now you might see all of these exponents here. They go up to the 6th power, but we can work this out. Because now, okay, all of these terms inside here have a w as a part of them, right? Specifically, we have 6, 4, and 2, which means that we have really 2 w's, or w squared in them. Sorry, w times w. So we have 5, and this is going to be times w squared times w to the 4th, okay, plus w squared times negative 5 w squared, okay, plus w squared times 6. Okay, so now we can factor out that w squared. Okay, bring it to the outside of our parentheses. Equals 5w squared times w to the 4th minus 5w squared plus 6. Okay. Now you may be thinking that we're done here, right? We haven't factored anything higher than, well, okay, something that looks like this. We haven't really factored anything above a quadratic, right? Sure, we've factored cubic ones before, but that was after we took out a common factor, which usually had an x, or we factored by grouping. Right? This one's a bit more subtle. Okay. So look at this here. Okay. I'm going to take this over here, okay, this w to the 4th minus 5w squared plus 6. And we are going to factor it using what we already know. Okay. Move 1 over. What if I did this? Okay. W squared squared. Okay, that would give us w to the 4th minus 5 squared to the 1st. Okay, that would give us w squared, just as before, plus 6. What does this look like right now? What if instead of w squared I wrote x? So what if I did x squared minus 5 times x plus 6? We can factor this now. We know how to do this, right? what two numbers multiplied together give us a positive 6 and added together will give us a negative 5? 2 and 3. Right? One will be positive, one will be negative. Or no, they'll both be negative, won't they? Because negative 2 times negative 3 would be positive 6. Negative 2 plus negative 3 would be negative 5. So we can rewrite this as x minus 2 times x minus 3. Okay? Now at this point, we've technically factored it. But what was x? Okay, we didn't have x in the original equation, we had w. Well, what did x stand for? X stood for w squared. Minus 2, w squared minus 2, w squared minus 3. We have factored this one. And so now we can take this back in. Okay, we factored w to the 4th minus 5w squared plus 6 into these two factors here. So we would get, okay, whoops, over here, 5w squared times w squared minus 2 times w squared minus 3. Well, how about that? We completely factored that one. Okay. Now we want to keep everything as nice integers, so we're going to call this our final answer. 5w squared times w squared minus 2 times w squared plus 3.